What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about computer system redundancy practices such as geographical dispersal, disk redundancy, network redundancy, and power redundancy. You also will learn about data replication and the main differences between on-premises versus cloud-based redundancy. Let's talk about redundancy. So redundancy in cybersecurity means building multiple resources that serve the same function and can replace each other in the event of the loss of primary system resources. When systems are not designed or configured with redundancy in mind, a single point of failure can take down an entire organization. Redundant systems allow for high availability and fault tolerance. Redundancy ensures that systems are always available in one way or another and with minimal downtime. And several key factors that are used to produce redundant systems are geographical dispersal, disk redundancy, network redundancy, and power redundancy. So geographical dispersal. This is the distribution of mission-critical components or infrastructures, such as servers across multiple data centers that reside in different geographic locations. Geographical dispersal acts as a safety net in case the primary site falls or in the event of a disaster or an outage that impacts an entire region. Should a workload fail due to hardware, networking, power, or some other issues, it can fail over to one of the alternate locations with minimal impact to the service. That way, the business can continue to function as normal. Next, we have disk redundancy, and this is the writing of two or more disks at the same time. Having the same data stored on separate disks enables data to be recovered in the event of a disk failure without resorting to expensive data recovery techniques. And implementing disk redundancy starts with setting up appropriate RAID and controllers that is capable of performing RAID functions at various levels. So let's talk about RAID types. So first, RAID, that stands for Redundant Array of Inexpensive or Independent Disks. And this is the data storage virtualization technology that combines multiple physical disk drive components into one or more logical units for the purpose of data redundancy, performance improvement, or both. And here are some of the most common RAID levels that are used. The first one is RAID level 0 or RAID 0. This is also known as a striped set or a striped volume, which splits or stripes data evenly across two or more disks without parity information, redundancy, or fault tolerance. The drives are treated as a single drive, and the drives are used to simultaneously store different portions of the same file. Striping boosts performance, but if either drive fails, then all data will be lost. So do not use striping for data drives. Next, we have RAID level 1 or RAID 1, and this consists of an exact copy or mirror of a set of data on two or more disks, and changes to the contents of one drive are immediately reflected on the other drive. This configuration offers no parity, striping, or spanning a disk space across multiple disks, since the data is mirrored on all disks belonging to the array, and the array can only be as big as the smallest member disk. This layout is useful when read performance or reliability is more important than write performance or the resulting data storage capacity. The array will continue to operate so as long as at least one member drive is operational. Next, we have RAID level 5 or RAID 5, and this consists of block level striping with distributed parity. Three or more drives are treated as a logical array, and parity information, which is used to recover data in the event of a drive failure, is spread across all drives in the array. And this is suitable for use with program and data drives. And then we have RAID level 1+0 or RAID 10. And this is when four drives combine striping plus mirroring for extra speed plus better reliability. And this is suitable for use with program and data drives. In RAID 10, this is essentially a striped set of mirrors. Now, with most PCs with RAID support, they do include support for levels 0, 1, and 10. In some high-performance desktop systems, they also support RAID 5. In systems that lack the desired level of RAID support, they can use a RAID add-on card. And another aspect about disk redundancy is called multipath. So multipath input-output defines more than one physical path between the CPU and the computer and its mass storage devices through the buses, controllers, and bridge devices connecting them. An example of a multipath path will be a SAN or a storage area network, which allows for the creation of two paths from the server to the SAN switch, providing control from the SAN switch to the storage controller all the way to the disk. Let's talk about network redundancy. So this is a duplicated infrastructure where additional or alternate instances of network devices and connections are installed to ensure an alternate path in case of a failure on the primary service. This allows for a business to remain online and be available in the event that the main path of communication goes down. And there are two main components of network redundancy that you need to know for the Security Plus 601 exam. And the first one is called a load balancer. So load balancing, this refers to the process of distributing a set of tasks over a set of resources or computing units with the aim of making their overall processing more efficient. Load balancing can optimize the response time and avoid unevenly overloading some compute nodes while other compute nodes are left idle. A load balancer is a device that acts as a reverse proxy and distributes network or application traffic across a number of servers. Load balancers are used to increase capacity or concurrent users and reliability of applications. And the next one you need to know about is called a network interface card teaming, or NIC teaming. So NIC teaming, this is the process of combining multiple network cards together for performance, load balancing, and redundancy reasons. You would use NIC teaming to group two or more physical NICs into a single logical network device called a bond. NIC teaming is also referred to as load balancing failover, bandwidth aggregation, traffic failure, and then it has a couple other names that it goes by, but those are the main names that it is often referred to as. Let's talk about power redundancy. So power redundancy, this is more commonly found in servers and other high-end computers where the redundant power supply contains two or more power supply units inside of it. Each power supply is capable of powering the entire computer and only runs one at a time. If one fails, the other power supply starts running to keep the computer powered up. The switch between the power supplies is seamless so as not to interrupt the normal use of the computer. The redundant power supply is important for servers and other high-end computers simply to minimize the chance of a complete computer shutdown or failure. And aspects about power redundancy that you need to know for the Security Plus 601 exam are the following. The first one is called an uninterruptible power supply, or an UPS. So an UPS, this is an electrical apparatus that provides emergency power to a load when the input power source or mains power fails. An UPS is typically used to protect hardware such as computers, data centers, telecommunication equipment, and other electrical equipment where an unexpected power disruption could cause injuries, fatalities, serious business disruptions, or data loss. An UPS differs from an auxiliary or emergency power system or standby generator in that it will provide near instantaneous protection from input power interruptions by supplying energy stored in the batteries. Next, we have a generator, and this is a device that converts mechanical or chemical energy into electrical energy to provide power to spaces and devices during complete power loss, blackouts, or in areas where standard electrical service is not available. Then we have what is called dual supply, and this is power that is supplied to a building via multiple paths to ensure a single path failure does not interrupt power to the building. And then we have what is called a managed power distribution unit. And this is essentially a power strip with multiple outputs designed to distribute electric power, especially designed to deliver power to racks of computers and networking equipment that's located within a data center. All right, let's talk about replication. So replication, this is the process of copying data from one system to another so that a specific data set is in one or more locations. And two components of replication that you need to know for the Security Plus exam are the following. The first one is called a storage area network, or a SAN. And a SAN, this is a computer network which provides access to consolidated block level data storage. SANs are primarily used to access data storage devices such as disk arrays and tape libraries from servers so that the devices appear to the operating system as direct attached storage. A SAN typically is a dedicated network of storage devices that are not accessible through the LAN. And then we have a virtual machine. So a VM, this is an emulation of a computer system created by a hypervisor. VMs are based on computer architectures and provide the functionality of a physical computer. Their implementations may involve specialized hardware, software, or a combination of the two. A VM uses a hypervisor for access to memory, CPU, the network, video, and other resources. And finally, let's talk about the differences between on-premise versus cloud-based redundancy. So on-premise redundancy, this provides rapid recovery for small and localized events, such as a server failure, rack failure, or a single source power failure. In the event of a catastrophic failure, on-premises recovery can take a very long time, which may involve locating and replacing damaged equipment and locating operational space to stage a recovery, which could add to the delayed recovery of the business operations. And then we have cloud-based redundancy. This allows enterprises to recover in a moderate to rapid manner depending on the deployment of the resources. Cloud-based failures could extend a company's recovery time by days, if not weeks. Therefore, it is of extreme importance for a company to regularly back up its cloud-based assets. All right, so that was my class on redundancy, where we talked about computer system redundancy practices such as geographical dispersal, disk redundancy, network redundancy, and power redundancy. And we also talked about data replication and the main differences between on-premises versus cloud-based redundancy. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.